Alright, so in this problem, I have 3 to the power of n minus 2 to the power of n is equal to 65. So to solve this, I'm going to first start by rewriting 3 to the power of n as 3 to the power of n to the power of 1. And I have minus 2 to the power of n to the power of 1 is equal to 65. And anything to the power of 1 is itself, so 3 to the power of n to the power of 1 is simply 3 to the power of n. Now, I'm going to rewrite 1 as 2 over 2. And 2 over 2, that's 1 again, so it's the same exact thing. And I'm going to do the same for 2 to the power of n. So now the reason I did that was because if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So n times 2 over 2, that's the same thing as 3 to the power of n over 2 times 2. Or sorry, to the power of 2. And the same thing for this. Now I'm going to let 3 to the power of n over 2 equal a, and 2 to the power of n over 2 equal b. So now I have a squared minus b squared is equal to 65. And a squared minus b squared, that's the same thing as a plus b times a minus b. And 65 I can rewrite as 13 times 5. So I have a plus b times a minus b is equal to 13 times 5. And we can say that a plus b is equal to 13 and a minus b is equal to 5. So now I have a system of equations. And to do this, I'm going to cancel these two out, add a and a, so I get 2a is equal to 13 plus 5, which is 18, meaning a equals 9. And if a equals 9, I can go ahead and plug in back to this one of these equations I'm going to do here, so I get 9 minus b is equal to 5, meaning b is equal to 4. So a equals 9 and b equals 4. Now remember how we let a equal 3 to the power of n over 2. So 3 to the power of n over 2 equals 9, meaning n is equal to 4. And 2 to the power of n over 2 is equal to 4, meaning, again, n is equal to 4. So this is my solution. Alright, so in this problem, I have x to the power of x to the power of 6 is equal to 144. So to solve this, I'm going to start by taking the power of 6 on both sides. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. And this is the same thing as a to the power of n times m. So x to the power of x to the power of 6 to the power of 6, I can actually switch these two places. So now I have x to the power of 6 to the power of x to the power of 6 is equal to 144 to the power of 6. Now I'm going to let x to the power of 6 equal to the variable y. And now, because we have 2x to the power of 6 over here, I can simply substitute in y for x to the power of 6 into my equation. So if I do that, I get y to the power of y is equal to 144 to the power of 6. Now what I'm going to do is rewrite 144 as 12 squared. So now I have y to the power of y is equal to 12 squared to the power of 6. So now what we're going to do is remember how we have this property. If I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m, as well as a to the power of n times m. So I have 12 to the power of 2 to the power of 6, and this is the same thing as 12 to the power of 2 times 6. And 2 times 6, that's equal to 12. So I have y to the power of y is equal to 12 to the power of 12. And if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, y to the power of y is equal to 12 to the power of 12, meaning y is equal to 12. And now remember how we let x to the power of 6 equal to y. So I have x to the power of 6 is equal to 12, meaning x is equal to 6 root of 12. Alright, so in this problem, x to the power of 2x plus x to the power of x is equal to 20. So to solve this, I'm going to first rewrite x to the power of 2x as x to the power of x to the power of 2. And I can do this because if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So now, I'm going to let the variable y equal x to the power of x. So now I have y squared plus y is equal to 20. Now from here, I'm going to subtract 20 on both sides. So then these two cancel out, and I'll be left with y squared plus y minus 20 is equal to 0. Now, y over here, I can rewrite this as 5y minus 4y. And now, the reason I did this is because I can factor by grouping. So for y squared plus 5y, I'm going to factor out y. So now I have y times y plus 5. And from negative 4y minus 20, I'm going to factor out negative 4. So I have negative 4 times y plus 5. Now, from the entire equation, I'm going to factor out y plus 5. So now I have y plus 5 times y minus 4 is equal to 0. So this actually gives me two equations. I get y plus 5 is equal to 0, and I get y minus 4 is equal to 0. So y minus 4 equals 0, y is equal to 4, and for y plus 5 equals 0, y equals negative 5. Now, because this is negative, this is not possible, because notice how y is equal to x to the power of x. So you can't take the power of a negative number and make it positive. So I get 4 is equal to x to the power of x, and we have to find a number that works out for this. Well, the only number that is small enough is 2. So x equals 2 because 2 to the power of 2 is 4. So 2 is my answer to this equation.